What is indefinite integral of 1 divided by 2x minus 3 raised to 4 by dx? Usually, we have some additional info about function f of x. In our case, f of x belongs to real numbers and is integrable in that domain. From symbol dx, we know that the differential of variable x indicates that the variable of integration is x. In that case, to solve this integral, we may apply so-called u-subtraction method. We do it in order to modify the integral in the way that enable using some of formulas for finding integrals. But first, let's modify our integrand using formula 1 divided by s equals s raised to minus 1. In our case, s is 2x minus 3 raised to 4, and our main equation will now be 2x minus 3 raised to 4, and this whole expression raised to minus 1. Then, let's apply formula which says that s raised to n and then raised to m equals s raised to n multiplied by m. In our case, s is 2x minus 3, n is 4, and m is minus 1. Now we have integral of 2x minus 3 raised to minus 4 by dx. Now it is a good time for substitution. We try to substitute expression 2x minus 3. We say u is equal to 2x minus 3. We also have to know what is the derivative of u. So we write derivative of u equals to d 2x minus 3. From rules that we can apply to derivatives, we know that derivative of 2x minus 3 equals derivative of 2x minus derivative of 3. Thus, we have du equals d 2x minus d3. We also know that the derivative of constant is 0. Consequently, our derivative of 3 is also 0. And we've got du is equal to 2 dx. But what we want to have is expression that we insert to our main solution instead of dx. So after division of both sides by 2, we've got du divided by 2 is equal to dx that we were searching for now. Let's make use of our u. We insert u instead of 2x minus 3 to our main equation, and instead of dx, we now use expression with our substituted variable u, which is du divided by 2. We have now integral of u raised to minus 4 by du divided by 2. Next, we try to modify our main equation to the form which enable using some known formulas for solving integral. First, knowing that integral of a multiplied by s by ds, where a is some constant, equals a multiplied by integral of s by ds. We may apply it to our equation. In our case, s is u raised to minus 4 and a is a half. Now we have a half multiplied by u raised to minus 4 by du. Perfect! Now we can apply formula for solving integral of s raised to n, which is s raised to n plus 1 divided by n plus 1. We also have to add constant c to make sure that we have all our solution taken into account, as our solution make whole class of function, not a single one. In our case, s is equal to u and n is minus 4. We've got a half multiplied by u raised to minus 4 plus 1 divided by minus 4 plus 1 and plus constant c. So we may write it as a half multiplied by u raised to minus 3 and divide by minus 3 plus constant c. Thus, we may multiply a half by u raised to minus 3 divided by minus 3. We will get in the numerator u raised to minus 3 and in denominator minus 6 plus constant c. We want to get rid of minus in denominator. To do so, we multiply the whole expression by 1. We can always make 1 from -1 divided by -1. It is still 1. But in our case, it enabled to get rid of minus in denominator, as minus multiplied by minus is a plus. In result, we have minus u raised to -3 divided by 6 plus constant c. Next, we can use formula which says that s raised to -n is equal to 1 divided by s raised to n. In our case, s is u and n is 3. In the main equation, we have -1 divided by 6 multiplied by u cubed plus constant c. But it is not the end of our solution. We have to come back to our problem, and it was formulated using variable x. We use u substitution, and now we have to come back to x. So instead of u, we now insert 2x minus 3. We've got -1 divided by 2x minus 3 raised to 3 plus constant c as a result of our problem. Finally, indefinite integral of 1 divided by 2x minus 3 raised to 4 by dx is equal to -1 divided by 2x minus 3 raised to 3 plus constant c. If you have any questions, just write them down in comments section below. If you want to see more our videos, don't forget to subscribe.